Hello everyone, this is Saisri and welcome to my channel. So in this video, let us answer an important question from engineering physics. So this is the second question from engineering physics, that is, explain the construction and working of helium neon laser. In our previous video, we have discussed the ruby laser. So it is a 3-level laser. Here it is 4-level laser. So first of all, in 1961, A. Javan, V. Bennett and D. Hammond reported a continuous helium neon gas laser. So in previous one, a ruby laser is not continuous, it is pulsating because it cannot have population inversion all the time. But here we have population inversion all the time and we will have continuous laser. So to construct a laser, we need active medium, pumping system or the exciting system, and the other one is resonant cavity. So here the active medium is the gas laser consisting of fused quartz tube. Here the material active medium is gas, fused quartz tube with a diameter of about 1.5 centimeters. This tube is filled with a mixture of neon. So here we use two materials. One is neon and the helium, in which helium is maximum. Means helium is more in amount than the neon. Why we use helium and neon means those two higher excited states are almost equal because these two are noble gases, right? So higher energy level states are almost equal. So we use neon and helium. What is the purpose of helium means it helps the neon to go to the excited states. So this is about the active medium. So here we use neon and the helium. And the pumping system. So we need a pumping system, right? So to send the ions or the atoms from the ground level to the excited level. The pumping is done through the electrical discharge by using electrodes that are connected to a high frequency alternating current source. So here we can see we can have electric discharge. So electric discharge will be taken place by using these two electrodes so that the electrons will flow from these directions. And we use a high frequency alternating current. What we use? High frequency alternating current source. And these helium, and also we need helium atoms also because these helium atoms only excite the neon atoms to the excited state. Here the main part is neon in producing laser beam, but the helium also helps the neon to go to the excited state. So this is the purpose of using the helium. So helium atoms are used to help in the excitation process. Resonant cavity is same like the ruby one. At one end of the tube there is a perfect reflector, while on the other end there is a partially reflector. The active material is excited by means of a high frequency generators with a frequency of several tens of megahertz and input of about 50 watts. So here we use a partially reflecting and fully reflecting end faces as like as rod ruby laser. The active material is excited by means a high frequency. So here we use discharge electrical source in which it is having high frequency generator with a frequency of several tons of megahertz and input of about 50 watts. So now let us see the working. It is a 4-level laser. So let us understand the diagram clearly so that we can understand the working of the helium neon laser. So what happens? Let me tell me. So first of all, what we have to do? Pumping or sending the atoms to the excited state. When a discharge is passed through the gas mixture, helium atoms are excited to higher energy levels E2 and E3. So they will acquire energy. So whenever the electrodes are given a electrical discharge, they will send some electrons into the laser, into the tube, quartz tube. So these electrons collide with each other and acquire some kinetic energy, and they will jump to the metastable states E3 and E2. So this is E2. So they will move to E2 and E3. So these two are metastable states. So these are the excited states. Because of the collision, they will go to the E3 and E2. With what collision? With the electrons, they will collide and they will go to the E2 and E3. Where these electrons produced means when there is electric discharge through the electrodes, the electrons are produced. And the helium atom, this is the ground state of helium, and this is the neon state, ground state. Now these helium atoms go to the matter stable state E2 and the E3. Now what happens? We need neon. So neon have to go to the metastable state or the higher excited states. Now the helium ions which gained more energy or which is having more energy, they will collide with the neon atoms and make them to go to the excited states. Now the excited helium atoms collide with the neon atoms inelastically, means there is no loss of energy with the neon atoms, and they will transfer energy to the neon atoms. So when these excited helium atoms collide with the neon atom, they will give all those energy to the neon atoms. So the neon atoms has maximum energy. So these neon atoms will go to the matter stable states E5, E3 and E4. So these three states it will go. So now what happens? So here we can see that E4 and E5, these two are metastable states. So these will have more lifetime. That means 10 to the power of minus 3 seconds. But this one, this is not a metastable state. It will have 10 to the power of minus 8 seconds. So when the neon atoms excited to the metastable state, so here these two are metastable state. So here some of the ions will be there, or the some of the atoms of the neon. So here we can have some atoms, here we can have some atoms. So here we don't have any atoms, so easily the population inversion takes place. Here we have more, so atoms in E5 or E4 are greater than E3, so easily the population inversion takes place, because here we don't have any atoms. If we reach only one atom here, then we can have population inversion, or two atoms we can easily get population inversion if two or three neon atoms will go to the metastable state. So in this way the population inversion takes place between E5, E4 and the E3. Okay, now there is a population inversion. So what will happen next? Now after 10 to the power of minus 3 seconds, so the atoms comes to the E3 state. E3 state. So they will fall to the E3 state. So because of this, one photon is released. So if it comes to from E5 to E3 or E4 to E3, it will release a photon. So this photon again it will triggers the atoms here. Neon atoms excited, neon atoms will be there, right? So this released photon will trigger these atoms. So these atoms will be triggered by the whatever the photon come when it jumps from E5 to the E3, this photon will trigger the atoms or the excited neon atoms in the metastable state. As a result, two more photons are formed. Again, these two more photons, again it will trigger the neon excited atoms in the metastable state. As a result, these photons will move back and forth, backside and forth side of the these end faces we have, right? These end faces, they will move this side and that side, and the light amplification will takes place. So again these two will become 4, these 4 will become 8, and these 8 will become 16. So like that the light amplification takes place. So in this way, after some time, when it reaches maximum level, then we can see the laser beam from the partially reflecting silver coated end. So in this way laser transition takes place. If this after some time, so these neon atoms will come to the E2 level or the even level with the spontaneous emission or de-excitation. They will release their energy and come to the ground state. And again, if one neon atom will go to the metastable state, again it will have population inversion here or here. So in this way we can have the constant population inversion in this helium neon laser. So let us understand again. So when a discharge passes through the gas mixture, helium atoms are excited to higher energy levels E2 and E3 through collision with accelerated particles. So first of all, helium will absorb some energy from the discharge tube and they will reach to the E2 and the E3 levels. Next, here E2 and E3 are metastates from which there are no allowed transition. So here we cannot have the laser transition, but only the helium atoms will go to the metastable states. These will help the neon atoms. The excited helium atoms then collide elastically with the neon atoms in ground state and transfer energy to them. So whatever the energy the helium atoms are having, they will transfer to the these neon atoms. So the now the neon atoms will get sufficient energy and they will move to the air metastable states, that is E5, E3, E4, E5. After collision, the helium atoms are returned to the ground state. Okay. So now these helium atoms given all those energy to the neon atoms. So then uh, the helium atoms again comes to the ground state. The higher neon state E4 and E5 are metastable states and have longer lifetime. So here E4 and E5. E4 and E5 have metastable states. So they will have more lifetime. So that the atoms can stay more time in the E4 and E5. So population inversion takes place between E5, E4 and E3. So in these three places the population inversion is there. If one atom or two atoms are there in the E5 and the E4, simply we can get population inversion, because in E3 state there are no atoms. So simply we can get population inversion between E5, E4 and E3. So because of this reason the laser is continuous, because the population inversion can be attained easily if there is one atom or the two atoms. This photon travels through the gas mixture. If the photon is moving parallel to the axis of the tube, it is reflected back and forth by the mirror ends until it stimulates an excited neon atom. So whatever the photon is produced, this photon triggers the another neon atom in the excited states and causes stimulated emission. Stimulated emission. So due to this stimulated emission, we get a photon. So here we have two photons. These two photons triggers another two photons and produced 4, and 4 continuously produce 8. So in this way the process goes on. Thus it causes a fresh photon in phase with the stimulating photon. The stimulated transition is laser transition. So after some time it will get maximum energy and it will appear as a laser beam which is coming from the partially refracted end. The process continues till a beam of coherent radiation build up in the tube. When becomes sufficient intense, so when it becomes sufficiently intense, more bright, a portion of it escapes through the partially silver end. So this is the process or the working of the helium neon laser. Characteristics of helium neon laser is type. It is a 4-level laser in which there are 3 levels in the neon. So one level means it will excite to the excited state. So helium first will go to the excited state, and 3 levels means one is a ground state, metastable states. We have two metastable states, right? So metastable state and one is E3. These three are 3 level energy levels of the neon and one is excited state of the helium. Active medium is helium neon gases. Pumping method, electric discharge we use to achieve population inversion. And optical resonators, a plane of plane mirrors facing each other is used. Frequency of output is 4.7 to 10 Hz. Wavelength is 6328 angstroms. Nature of output is continuous. Here it is continuous because population inversion can be attained easily. Power output is 0.5 to 50 milliwatt. Next, what are the advantages? No cooling is required. Here there is no heat produced in this. And this operates in a continuous wave mode. We have continuous laser. More monochromatic and more directional than solid state laser. High stability of frequency. And the applications are laboratory experiments to produce interference, diffraction and patterns. Optical communication without fiber for moderate distance. So for little distances we can use this. Aligning the ruby laser, aligning the ruby laser, and the ophthalmology, in the ophthalmology, and produce holograms, that is the 3D photographs. So these are the uses of the helium neon laser.